Hey everybody, welcome to another HashiCorp user group Sydney session. Today we're going to be talking about Google Cloud Platform and GKE. So today we'll be provisioning a Kubernetes cluster in Google Cloud Platform with Terraform, and we'll go over the initial setup, and then we'll also show you a repository that you can use as well if you want to do this on your own. So Ben, would you like to introduce yourself, please?
Hey everyone, my name is Ben, as Brad mentioned. So Brad and I have been running this HashiCorp user group Terraform talks for a couple of weeks now, and yeah, it's always fun being here to chat and impart some knowledge and wisdom that we've sort of been gathering across this time. So yeah, if anyone wants to participate and join in these talks, we're always happy to take on more speakers. So let Brad or myself know.
Thanks, Ben. Okay, we'll get started. So today this is what the outcome of today will be. We'll create a Kubernetes cluster that you can have under infrastructure as code. And yeah, we can go over, the networking, IAM, cluster subnets, service accounts, etc. So like I said before, if you want to use the code, it's I haven't updated this because last time we did one on AKS in Azure, so we also have code for that as well if you want to use it. I just have to push the new code. So how we do it is we reference Terraform modules through Git. So they can be found in this one as well. You don't really necessarily need that repo because we just reference it. So you can see here, this is split by providers. So this is the Azure RM, and then we have Google as well. So within this, you can see that we have all the ones we're going to use today, a lot of networking, IAM, and there's a database if you want it. We probably won't do that today. And container node pool and the container cluster will be the main ones that we'll talk about. Also, all of the sorry, Ben.
Yeah, we're going to show this later, but in terms of how do you actually reference these modules from your code? Because like what you said, Brad, this is available on public GitHub, so you can actually use these same modules without, it's publicly accessible. All you need to do is put in that source exactly as you see in there, GitHub, Brad, McCoy, Dev, Terraform modules, and you'll be able to reference those modules and just pull it down to use it yourselves.
Yep. And if you want to add another module, you're welcome to do pull requests as well. So all the great thing about Terraform is the documentation as well. So any providers, today we're using Google, but you can see that they have really extensive documentation for every module that they have. So here you'll see container cluster, and yeah, it's really helpful information. Like, make sure that you always read these notes because as things change over time, you need to be sure that it's not going to cause breaking changes for you as well. So you can essentially copy and paste this to make a module as well that we'll go over soon. And then yeah, and if anyone has any questions as we go, please let us know, and we're more than happy to answer them.
Yeah, good providers like Google and Azure, I assume AWS would do the same thing. Whenever you try and run a Terraform module, and if an argument is deprecated, you would actually get a yellow warning labels there saying, say example, add-on configs is now deprecated, use add-on something else instead. Usually the providers are pretty good in giving you warning that a feature should be replaced with something else. But docs is always your single source of truth.
Yep. Okay, so let's get started. So the first thing that you need is actually G-Cloud. So you can, I won't go over today about how to do it, but essentially you just say install G-Cloud. So that's a CLI. You can obviously do it in Linux, Mac, Windows, or whatever computer. Well, those are the computers that you generally have. And you can follow. It's very simple to follow the documentation to install that. I think for me, I'd use brew and just go. Probably didn't actually. Yeah, but yeah, you can go to the cloud.google.com SDK docs, and then you'll be able to download gcloud. So one thing I've made today to make it helpful for people is a bash script, and I guess you can still run that on Windows if you have set it up properly. So what this bash script does is it's gonna, because in Google Cloud Platform you need to make a project for this to contain, to be in there. Technically, you can make a project in Terraform as well, but I probably did this like a year ago, so there would have been a reason that I'm doing it in here, and I think it's more around when I generate credentials for Terraform to use, because I want to put that in the pipeline. I set this up first, so you can see here using the CLI, I'm saying projects create, I'm configuring my region, and then creating a service account for that to be used, and then you can see here that on that project, I'm going to enable the Google Cloud APIs that we need. So this is when I used to use Cloud Build, so technically we don't need that, but I'll just leave it in there. But yeah, container registry, billing, IAM, compute, container, those are the things. Because so if you tried to run Terraform and you didn't enable that, it would say like, okay, this is an error because you haven't enabled. It's sort of like Azure as well, Ben, where for some features in the subscription you have to add. A little bit annoying, but I guess it's a safeguard if people start, spinning up something they shouldn't be, or
Gives you a bit of warning before you deploy, a virtual machine in a project that was freshly created, and you didn't actually want that subscription to contain virtual machines. I mean, that project subscription.
Yeah. And then this does a little bit around the IAM policies and bindings as well. So, and in the end, it's going to create my provision GCP script. So that's the one that I'm going to use in the pipeline as well to authenticate with GCP, to be able to, deploy my resources. So any questions about that, anyone? It's pretty straightforward.
Would that be only on the first run where you're enabling everything, or is that, you would do that often?
This is this is only on the first run for generally I segregate environments by project as well. So I will actually run this for each environment as well. Yeah. And then we have the Terraform provider as well. So let's just look at what that looks like as well. So here we have provider is Google, and then on the documentation you can see here as well that references Google. So it's in Terraform, they always have provider at the start underscore and then your resource. So you can see here that soon I'll run the script, but after I run the script, that it references those variables that I had, and that's what authenticates. Instead of using my Brad, email, it's going to use my service account instead. So, and here I'm specifying the backend, so that's for the state file. Maybe Ben, you can talk a little bit over the state file as well.
Yep, sure. So if you've worked with Terraform, you would be aware that Terraform stores its metadata in a state file, and you either store it locally, which you would almost never do, or you store it in a cloud storage. So for Azure, you would use your storage account. In Google, similar, you just chuck it up in a storage, and in that way, you're allowing people from your team to be able to access that remote state and get a ledger of what has been deployed, what's the current state of the deployment, basically. So that's what a state file would do.
Yep, thanks, man. And also, one thing to note as well, that we have variables. So I think, yeah, we'll just go high level overview of this whole repo and what it contains, and then we'll go execute it all. So we talked about state. So yeah, the state is the ledger of what the desired state is and what the current state is, and then that will reconcile when you run the apply command. So we're going to use variables as well. So you can see here that I generally do client ID, project ID, environment, and even if you do it for personal projects, I always keep the same, because if you go to a company and implement this, you can use that same approach, and it's very scalable. So, you know, one client can have different projects and environments. So I find this hierarchy quite good. So yeah, so hopefully today we'll get a few errors as well. I'm anticipating a few, which will be good, because in the real world, you'll get a lot. So we can work through those as we provision it as well.
It never works the first time around when it's a Kubernetes cluster.
Yeah, I actually like to come to these with errors now, because I feel like it's a better demonstration instead of, you know, everything just working, which doesn't really happen. So let's look at Kubernetes. So okay, so I've got locals here as well. So locals will be in here. So that essentially what that's doing is that's just all my tags here I'm defining, so that will be put onto each resource, because we like to tag consistently. So, and then we have, if we want to go multi-region as well, we generally, if we look over here, Ben and I like to alias so here you can see, like, you can do the regional cluster or have it in the different availability zones as well. But we generally like to, for our naming conventions, use the location as well, because if you go multi-region, you generally want it to be the same, but just the different regions, so you can see it in the portal if you're looking at it.
While you're there, your US West 2 is using the same alias as US West 1.
Correct. Yep. We've still got a little bit of work to the variables before we provision it. So, okay, and then, so pretty much today what we'll do is, first thing, yes, set up the project. Then we have networking here as well. So you'll see here that we're going to create a VPC, global address, networking connection, and the compute address. We can do a container registry as well, if we want to publish our Docker containers to that container registry also. So that pretty much just makes a storage bucket, and you can store your containers there. And then, yeah, last but not least, Kubernetes. So we'll have a container cluster that's sitting inside the VPC. And then we can also have a node pool as well that will be attached to that. So you can do really cool things with node pools as well to save money. So you can have, I think, yeah, see, it's called transient instance as well. So it's like spot pricing, where you only, you can say, like, I want to opt in to pay like half of what it's normally worth. And yeah, it's good. There's a lot of optimizations you can do for saving money in using Terraform as well, if you have the right configuration as a template. Okay, so let's just see what this shared name is going to be. So for here in the project, let's see what we're doing for the project ID. So that's shared name. So shared name is going to be project ID and environment. Okay, so that's good. So up here we're just going to, what do we want for the project ID, Ben?
Let's just call this Hug Demo, Hug GKE or something.
Yep. Sounds good to me.
Hug stands for HashiCorp User Group, in case people are thinking of Hug.
Okay, and then we have, yeah, I guess we can just say demo for the environment.
Yeah, the environment, just demo, I think.
Yeah, so also on the README, I've got some helpers as well. So I'll just change that to demo. So these are all the commands that you need for Terraform. So I'll just push all that up as well. And if anyone has any questions, just yeah, don't be shy. Okay, so you can see here as well, when we're making a project, Google Cloud project is going to be called Client ID Project ID Environment. So that's OC GKE demo. So we just want to be sure that our code in Terraform is reflecting the same thing. So that's going to be the shared name. So the shared name is going to be client project ID and then environment. So
we can add the client ID in there.
Client ID, yeah. It looks like we're going to have to add that. So yeah, we've got a little bit of work to do with variables, but that's probably the most thing we'll have to do for this anyway. So here we'll add client ID. So that's the main thing I was checking there, is that's going to be consistent because
you've got client twice in there.
Oh yeah, thanks. And we can see that as well if we go to our variable file, just to make sure that that's correct. Yeah, and then don't need to worry about that. The project ID, let's take it from our script. So probably what I could do in the bash script is update this after I run it as well, or the other way around to automate it a little bit more. So we can make a ticket to do that. And then this is going to be called demo as well. So I hope that makes sense what we did. Essentially, we're using the variables, so we don't have to write hard code things to modules. And then okay, so we can put the script will generate those credentials. These are our networking cider blocks as well. So you'll notice that we're doing demos at the moment for AKS, GKE, and EKS as well. So probably more in the future as well. But we generally like to keep our variables quite consistent with all clouds. So when we change, we just simply copy and paste these in, and it works quite well. So this is just the cider blocks for the networking that we want to do. And then there's some Kubernetes variables as well. So if we want the CNI that we want to use, can be Calico, and node disk size is 30. Yeah, node count. We can do auto scaling and things like that as well. We can tweak all that once we're up and running. Okay, so how does that look to you, Ben?
Looks pretty good. Okay. GKE, yep, they're all in line.
So we're probably good to start the script now, I guess. So we'll have to go into the scripts here. Okay, and then I'll just make sure there wasn't any special things that I had to run last time. Okay, so maybe it looks like I need sudo maybe, so let's just run that. Okay. One thing that you need to do as well is authenticate against gcloud. So you just go gcloud auth login, and then that will authenticate you in through the UI. You click your name. So see here, this is. I'll just explain that after. So this is running all that script, just that bash script with all the enabling all the APIs and stuff there. So we'll just wait for that to come through. Ben, you want to tell us any Terraform stories while we're waiting?
I can't think of any off the top of my head, but
do you have any GCP questions?
GCP. It's quite cool how because I'm primarily Azure, it's quite interesting seeing the difference between GCP and Azure and the way things are set up. Azure has its subscription, this has its projects, and above the projects, even the regions work slightly different between Azure and GCP. But that being said, the Terraform code is near identical between the GKE against the Azure's version of Kubernetes, Azure Kubernetes Service.
Yeah. And that's the beauty of, like, as a hiring manager, when someone says, I know Terraform very well, but I don't know Google Cloud, I wouldn't care, because like with Terraform, you can very easily automatically know Google in a way, right? Especially if you're living in a Kubernetes world where all you really need is a cluster and everything else you do is different inside. So yeah, it's quite cool.
Yeah, all you need to do is just map from like what's the equivalent of the Azure, this particular Azure parameter, then that you pass it to the GKE version. So it still works pretty well.
Yeah. And yeah, especially how we do the variables, so it's like quite consistent with all clouds. It helps as well.
Yeah, it's quite intentional how you see, like in line 10 there, cloud account ID. We don't call it subscription ID or project ID, because if you're using Azure, you're using a subscription, but then you would have to rename your variable when you're using another cloud. So we tried to keep it as cloud agnostic as possible.
Like cloud credentials, yeah. This shouldn't take too much longer to do. It looks like we're container APIs. And see, this is a cool thing as well that I actually forgot that I did, but I'm actually creating a bucket for my state file for Terraform. And then I'm setting versioning on it. That's very important when you're using Terraform and state, because if someone does something bad, you can roll back that version, and then you have your Terraform state file to roll back on. So yeah, I personally like to have separate buckets for state, especially if you have different clients that you don't want in the same project, due to isolation and stuff.
We tend to use like a prod and non-prod separation.
So you can see here in my README, when we initialize Terraform, yeah, see that's making the service accounts as well. So that's setting up all the IAM. So there's technically you can do some of this stuff in Terraform, but for me, sometimes you can't automate everything, especially the bootstrapping of a project and that. So I didn't want to be too fancy and just keep it. Sometimes simple is actually better. So yeah, that's why I have the script. And then you can see, so if we look at this one here, so we have I generally go in US because it's cheaper than Australia. Australia is one of the most expensive in the world. Okay, so see, that's all been done.
Great. We've got the keys, we've got all the credentials.
Okay, so it looks like this provision is not showing up in my script for some weird reason.
Yeah, it's kind of odd.
It might have to be, it might be maybe I have to give it from file permissions or some weird thing. Let's see if I've done this before. This is the thing I like about history is you don't have to solve the same problem. Yeah, so it looks like you have to give it looks like Google CLI will make it some sort of secret. So if we say here in the README, I'm glad that I'm doing all this from scratch instead of already half done, so it's easy. And then I'll just copy this to the README as well. I'll update that later with some notes around it. So if I run this, it should become visible. Okay.
Sudo chmod.
Yeah, true. But I don't know if that will even work. So yeah, I can do something on my other screen if we need to. Okay, so that I'll write in the README how to do that, by the way. Let me just quickly find it over here. And Ben, would you like to talk about the Terraform init plan apply while we're waiting, just in case people don't? Maybe just say why what I'm doing here with the backend, making it more dynamic and reusable.
Yep, for sure. So this whole right now, this backend, this init script isn't using environmental variables, but what we tend to do is, in like the very back last bit that you see there, prefix Terraform state demo, what we typically do is we put the environment as a variable. So you can run a Terraform init multiple times for swapping environments between, in this case, demo or test or prod. And what that then does in the Terraform plans down below as well, deployment / demo / environment, you would just essentially run the same script. So var file equals deployment / demo / environmental variable client environment. That way, you don't have to type it again and again. You just copy and paste from the README, which we tend to do. And copying and pasting tends to save you on errors by typo. We have made mistakes before where we tried to type this Terraform init script manually, and the moment you have a typo, it initializes into a completely empty state file, and that causes some complications. It'll think that you're trying to rebuild the entire cluster from scratch because the state file didn't exist. You just created a brand new state file purely because of a typo. So these copy pasting tends to save you a lot of grief from avoidable user error.
Yeah. Okay, you can see that actually came up now. So, it doesn't matter for sure. I'm going to delete it after. And I also, you can see here that I've put that in the git ignore. So we don't accidentally commit that and then you expose a secret, which lots of people probably do. So I've done local Terraform file state and lock. Those ones we don't need because I'm not using those. Yeah, so that was an example of setting up the project using that script. You can do it in the UI if you want, up to you. So now that we've set up, okay, let's actually go and look at that. So This is the wrong one. So here we'll just go have a look at what we've done, just to visualize it. I really like generating that JSON file straight away, because then you can use that in the pipeline and you don't have to worry about does it work on using my name and other sort of auth.
Yeah, service accounts, service principals, they work very well. Don't have to worry about RBAC for your typical dev or your, I don't know, team lead admin type user.
It's just running a little slow, it won't be long. Yeah, so one thing you got to be careful about is for some, this is the thing I hate, but it'll automatically take you to recent and you'll be like, oh, where's my new one? But if you go all, it'll show you. I've been caught out a few times with that. So here's the project that we created with the script, and then you'll see some basic like IAM around it. So one cool thing that we had in that script as well, set up GCP project. So you'll see that I added my email as a project admin to the project. So later on, once the cluster's up, I can then use a G-Cloud console to generate my kube config as well, which is pretty cool. So you can put your own name there as well. All right, so that's an example of creating the users, the project from the script, and then now we'll get into the Terraform. Just going to close all this. I think we'll go here. What do we need here? What I might do is let's look at this. Okay, let's look at the bucket that we used. See what's in here. Yeah, so this is the storage bucket I was talking about before. So there'll be nothing in it at the moment. So what I'll show is when we initialize Terraform, that will create the state file in here as well. So this is what the bucket is called. So we just have to make sure that, remember in our Terraform file,
the init script.
Yeah. So, yeah, there's two. Yeah, you're right. Sorry, I didn't know what you meant. So then the bucket here is going to be the one that we did, and then the prefix can be whatever you want. So you can see here that, okay, I want to use the provision GCP credentials that we made. I don't need it in this file anymore. I think that was just a weird bug with Visual Studio before, because it showed up on both of them. So let's go back. Probably, maybe we don't need. So let's try and initialize it. So what this will do is it will bring down the provider, everything that you need to deploy, and then it's looking at CRUD credentials. So let's just make sure that our file path is good in the variables folder. So this is all the variables we're using again. And then deployment. So we're actually, I'm not segregating that by environment at the moment. So that's just going to be pointing to that version file. Normally I put folders for environment if I'm doing, dev, UAT, staging, prod, etc. But today we're just doing demo, so I'll keep it easy. Okay. So let's try and initialize it and see what errors we get. There could be some variables that we need to update, I imagine.
One at a time.
And do you want anything else you want to say about init, Ben?
Well, in this case, it's going to be pulling, I believe, quite a number of modules because we've got a lot of modules in this particular repo. So it might take a couple of seconds or more.
Probably take a minute, yeah. So that's downloading the modules from the other GitHub repo. That's the beauty of it too, because you can source control. Okay, this is actually an annoying error that is hard to solve. I've had this before quite a bit. First thing, now that's not a very helpful error. This is good that we're getting it because it's quite common. Generally, it's a spelling mistake or something like that relating to the state file. So I doubt that this would have actually created a file. Let's just check. If it did, then we can troubleshoot from there. Yeah, okay, so it hasn't made it. So let's check spelling. So spelling becomes quite important here. So
Is
the
it
backend
complaining about the dot slash? Probably it shouldn't.
you mean
Like the, from current folder.
What we can actually do is, you're talking about that one there?
Yeah.
Yeah, probably.
Yep.
Because I'm in source. Yeah, I think you're right. So like that should work, eh?
Give it a crack.
And generally when I get an error, this .terraform folder, I just delete it to be safe. Just in case it caches any weird stuff. It saves time. Sometimes it's annoying because you have to download everything again, but I think it's worth it. Okay, so that's, okay, invalid. So maybe it needs brackets around it. I think it's just missing
quotes.
that. Quote, sorry, yeah, that's what I meant. Because it had one on that side, but it didn't have one there.
I think you need an extra quote because right now you've got quotes around credentials as a word. In the backend, config equals credentials.
Oh, yeah, okay, I see what you're saying. You're saying that. I think it's actually wrong there. It shouldn't be there. Hold up. Backend config equals. Yeah, it's missing there. It shouldn't be there. Sorry, I shouldn't have actually put that out, so it should be like that. Backend config. Let's see what the V says. If this doesn't work, I'll show you another way that we can put it in the.
Straight in the provider, I guess.
Yeah.
It's the alternative.
Yeah, that works fine as well. And then we can work this out at the end if we have time, but we don't want to waste time on something silly like that. Okay, that's fine. Let's do that then. Okay, so what we can do, what that's doing anyway is it's just overriding the default settings. So if we go, normally I have a Terraform.tf for that file anyway, which we can probably do to be, I like it separated. And then we can get this here. So say, okay, I need credentials. And let's just quickly confirm that. So I'll type in, I might even just copy that and see if that will come up in Google. The good thing is the documentation will tell us. Yeah, so you can see here that
Bucket
that's,
prefix.
yeah, how we need. So here we're saying the bucket is going to be that one. This might make it easy for people it's their first time anyway to not have to understand what that stuff does in it. And then remember that state can be anything. Terraform will make that in the storage account, which we'll show you later. And then the one that was failing was credentials. So it would have been a silly mistake, a spelling mistake that we didn't have time to look at.
This might need a dot slash. Would this need a dot slash?
Because we're in this, yeah, it would actually, yeah, because we're in the source folder. Let's confirm that actually. Because we're calling it from source, it would actually. Yeah. So essentially now we don't have to run.
You can just go Terraform init.
And var file.
Demo TFRs.
I forgot that. I think I'm actually referencing that file.
So hug demo.tfrs.
Oh yeah, there's two. That's why it was complaining actually. That's why it didn't work.
Yeah, there's no demo folder in there.
Yeah, exactly. But you see that's quite a weird error, to have for that.
It's not even deployment / hug demo. It's just deployment / provision GCP. There's no.
True.
Not for this credentials part.
Yeah, you're right. Okay, so how about now that we've added that in, we can either take it out or we can leave it. But I think for the demo, that might even be easier just to read it like that.
Yeah, for this, let's just put it in there.
Yeah. Okay, so let's just save that and then we'll run it again. So I hope everyone understands what we were just doing there. So now we're initializing it.
There you go.
Not yet. Yeah, so that works. So you can see like that was just our spelling mistake that you get a lot of this stuff when you're trying to do it for the first time as well. And sometimes you get generic errors, so just really look at your work and see what's happened. So now let's demonstrate in here what we actually made. So that will show you making the state file. So that's that references the state file in the cloud. You can run this locally as well. If you point to nothing, it will just download to your computer, but the beauty of remote is that you can work
as a team.
Anywhere. So
as a start, yeah.
I mean, storage is very cheap, if not free, so it makes sense to do that. And you can see that now my remote file is saved here. Good thing to do is put, no public access. encrypt it because this can contain passwords as well. So this, you should deem this as very sensitive. So make sure that no one else can, developers can't go in and read this file. So it just says default TF state, and that's just, if I click on that, that would show me all the state that we have today. So we've deployed nothing already, but you can download it if you really want for a backup. Okay, so now we've initialized it. Let's now see, we'll probably have some issues with our variables, so we'll just go over those one by one.
The var file itself is just hugdemo.tfvars, I think. Yeah, without the demo.
Yeah,
the var file.
It. Yeah. This is just from the last one I did. So I can probably be a little bit more consistent on that, I think. I'll change that if people want to use this to test themselves. So Ben, would you like to talk about plan while I do this?
For those that are familiar with Docker, plan is the equivalent of a dry run. Batch amount 0.
Yeah, I'll just get rid of these because
what this does is it essentially just gives you an output of, it compares the current state file, what it has against what you're intending to deploy, and it'll tell you, all right, I'm creating 5 resources, and there's an additional 2 resources that are modified rather than create. And if anything gets removed, it will also tell you that which resources are being deleted. The thing to note about plan against apply is that plan doesn't actually check. It doesn't actually do a full verification. So, for instance, if you named the storage account something that already exists, plan would say it'll create, but until you go to the apply stage, you won't get the error that says that this storage account name has been taken, for example. So plan is very useful for debugging purposes, but take the output with a grain of salt. It doesn't always reflect the most accurate result.
Yeah. Okay, so why this is doing this as well is that because I've gone to multi-region, I used to have cloud just for one, but now I've actually called it cloud location 1 because you can specify region 1 and region 2. So in this case, I'll just need to update the names of my variables. So now I'll call that location 1, and then that should fix that issue.
Underscore.
Yeah. Thanks. Okay, and then we should be consistent with variables now. So you can see on the left that this is my variable file, and then on the right, that's my variables TF, and that's declaring the variables that I have in this project. Okay, so what this is saying here is that for my provider, I'll show you here that we're saying cloud underscore credentials, and I have that here as well. And that's complaining because I haven't declared it in the variables, which we were just talking about before. So maybe Ben, also while I do this, you can talk about validation of variables as well, like an example.
Yeah,
sure.
Yeah. So this is a variable declaration. We tend to give it as good of a description as we can. Some things that are pretty self-explanatory, like client name, you don't really need a comprehensive description. But for cloud credentials and stuff like this, especially when it's an object, you could describe it a bit better so that the next user knows how to use it. And validations, as you see in that particular example, you can use validation for a whole number of purposes. We have used it for input validation. For example, in the client environment, we want users to use the word specifically prod, not production or anything else. So you can use validation to enforce certain naming conventions as well. Yeah, so like we try to keep with 3 to 4 character environments, dev, test, prod. We don't go, development or testing or any other name. So it's just hard enforcement.
Yep. Okay. Okay, so this is I was being fancy here with outputs. So can you please also describe outputs better, and I'll change it as well.
So outputs is something you can think of as an extension of your typical Terraform resource. So say if you did if you created a storage account using a resource, you are able to reference, say, the storage key to be used elsewhere. But when you're doing a module that could contain one or more resources, you need to actually specify what outputs you want to output from that module. So as an example, if you're creating, say, in like a cloud function type scenario, if your cloud function needs a storage account, you could build a module that has both the function and the storage account side by side. And in your outputs, you actually specify .id is the ID of the cloud function, .storage ID is the ID of the storage account. So you can name it anything you want. And it's the same thing as how we do it in variables. As long as you give it a good description, that way users down the track would know what the output actually does, what the expected result is supposed to be, if it's a string or a number, or how do you actually use it. So in this case, we've got a module called Azure RM Resource Group. Right, so this is when we were using a bit of, this is a full-on output. This is when we were doing AKS.
Yeah, this one's using Go syntax as well, which is great. This is just to get people to go into their cluster after it's provisioned, just to make it easier. So the output will be like, okay, thanks for provisioning. Here's your credentials. It'll merge your kube context, which is really cool. Okay, so I think for it's 1, 2, 3, 4, 1, 5 now, maybe 6. So here we can put like, you'd have to put client ID, la la la. For now, I won't do this. I'll do this at the end if we have time, because we've only got 7 minutes left. That will stop complaining if I do that. It looks like I need maybe one more after region as well. So you can see what I'm doing there. I think that should be right. And you can put as many outputs as you want. You might want to have like subnet ID, or in Terraform documentation, you can go see all of the outputs as well. So normally that's at the bottom of the page.
Yep, the attribute references for the shortcuts.
Yeah, this is massive. This one. Yeah, so you can get, generally ID is all we really need, because when you create something that depends on the ID, you can say, okay, this is my ID for, like, for example, if you're creating a cluster node pool and then you want to reference the cluster, you need the ID. So you say cluster.id when you're spinning up the node pool. Okay, so I think this is saying that it's not an array anymore. So let's go check that out. That's an auth. This is because I used to have a count in here. So the count is like, if your cloud provider's GCP, then count 1, else 0. So if that's my owner, so I think it's a case of just taking out this array.
Yeah, it's just taking out its zeros.
Yeah. I'm thinking maybe I might actually need that somewhere, but I guess. Oh yeah.
Or in the
that one, for
short term, you can
example.
just put the count back in for that one to make it not complete.
To be super easy, we'll just take count out. And then if I take count out, because we can deploy it anyway, it's fine. That was when I was using the same repo for all cloud providers, and I would just say, do you want this on GCP, Azure, or EKS? And then it would just spin it up, whatever I said. But I've sort of gone more to having it in separate repositories now. Keeps it nice and simple, because generally you're not really doing multi-cloud. Okay, so that should work. Might have a couple more errors in them, or it'll deploy. We've got a 4-minute challenge. It's good to leave it. Okay, so getting still more.
So this sounds like there's still an account somewhere.
Yeah, I was
line 133. Module Google Container Registry.
Oh, okay, so Google Container Registry, that probably has a count on that. Yeah. So if we take that out, I can probably say no, that's fine. That's acceptable. Auth line 135.
One last zero that got missed.
It's good to do demos like with errors there.
Mm-hmm.
Okay, perfect. So this is working good. You can see that we have 25 resources to add. So this is now validated. Terraform's correct. So it will tell us, okay, we're going to add all of these things to spin up your GKE cluster. Global address cluster. These are all my config. Yeah, all the node pools, everything. So this is looking good, and then we're ready to go apply. We might go a few minutes over today. We'll see how long it takes to. It normally takes about 10 minutes to push out, but hopefully it's faster today. And then you don't need to use necessarily environment variables. You could use the shared ones. Would you like to talk about the hierarchy of variables while I do this, Ben?
Sure thing. So Terraform takes in variables from multiple sources, one of it being environmental variables. So say, for example, we've had, like the client ID. You could pass in, instead of giving the value of client ID equals, I don't know, say client ID equals Brad, you could go and in an environmental variable tf underscore var underscore client ID equals Brad. And that way you don't have to pass in a value inside any of these tf vars that you see here. So that's the lowest level where it looks at environmental variable. If you specify that value again inside any file that ends in .auto.tfvars, as you can see on the left of the screen, shared.auto.tfvars, the one in white, So that takes precedence, and if you have values that is declared both in this shared auto TFRs and in an environmental variable, this will override it. And the next level up is in a specific thing like what we had just done, -var -file equals hugdemo.tfrs. So again, that overrides everything that goes below it, which is like the shared auto and the tf_var. So that's just this hierarchy of where Terraform can get its values from, and in terms and which one is more higher priority than others. The absolute highest priority is if you actually declare in your CLI, which you probably shouldn't do. You can go Terraform apply -var client ID equals Brad McCoy test, for example, as you can see in the very top there. So that explicit declaration in the CLI, that's the absolute most, I guess, the nuclear option. It'll overwrite everything below it. But generally, you would almost never want to be declaring anything in the CLI anyway. You would just leave them in these TFVars files.
Yeah. Let's put the video back on while we wait. So yeah, generally Kubernetes takes about 10 minutes in most clouds to provision, but you can see here that this is working perfectly. So I'll commit this once it's finished. We might as well wait for it to finish because it wouldn't be a demo if we didn't have it up and running. And yeah, I guess if anyone needs help, we're more than happy to help you if you need setup. It can be a little bit overwhelming sometimes. We've done it using best practices as well, so it's probably not the most simplest way to do it how we've done it, but it's the most scalable.
Especially with the transient, was it transient node? What was the word that GCP uses?
The transient, yeah.
So that actually gives you quite good value for money in terms of when you need to scale it up, you're doing it at a reduced price compared to a fully provisioned node. So that assists in when your cluster is under a lot of activity, you just scale up an extra node, and you get better performance at a lower cost. So it's a win-win.
And yeah, you can in the modules as well. I'll just go over that as well, actually. So there's some SQL databases as well. If you want to use that, you can. If you want to do this one yourself, you can just fork McCoy dev GKE, and don't worry about that. When I commit it, it'll push over it. We essentially copied it and then made it to work on GCP as well. So yeah, you probably don't need to know much about modules, but they're there. In summary, this is modules that we've made for each one. So you can see here that we're trying to make it easier for people. So you just need to know your variables, and then that will go and do everything for you. We'll keep making them better over time as well. And I guess one thing we didn't do as well for this one, Ben, was point it to a specific branch in the modules. I think we didn't do that.
Yeah, I guess keep the focus on the GKE rather than the module side, I guess.
Yeah. But we can add that as we make it better. Obviously, people want version control so it doesn't break their stuff. And yeah, in summary, we first bootstrapped the project with the setup GCP project. So that gave us the project and permissions that we need for Terraform to deploy. The cool thing about having this file is that we can just put that into a secret in GitHub or Bitbucket, whatever you use, and then that will be able to point to that remote state file and then provision it in the pipeline too. So when you commit code to this, it will work. And then we went over providers for Google. So for GCP, you use the provider here as Google. So you need that provider. Here we're using this backend Google state. So you can actually use Azure or AWS if you want. Just because you use a certain backend doesn't mean you can't do other providers in your Terraform. That's the cool thing about it, is you could actually, yes, have multiple providers in one project. So we sort of, in a way, hard-coded it there. You don't have to hard-code it. You can put it in when you run your Terraform in it as well. We also went over networking. Well, we didn't really go over too much, but essentially the code's there. So that's creating the network. We created a container registry as well. So, and then the auth also.
Yeah, and this one nifty little deployment, you've actually got a lot of things happening under the covers to build out your full GKE cluster.
Yeah. So it's all done for you, really. You don't need to spend all the hard time learning how it works. You just get your variables right of what you want, and then you're away. Any questions, Ben, on that side?
No, so far it's been pretty good, pretty clear.
Quite cool, isn't it? Like with Terraform, how you can go from not even knowing a cloud, and then you just read the Terraform docs, and then all of a sudden you're away.
It's darn near identical to AKS, which is pretty cool.
There's obviously you've seen how comprehensive the documentation is as well. So there's so much stuff you can add, and look, it's probably updated since I've done this code, but yeah, vertical pod auto scaling. There's so much cool stuff. You can put taints on your nodes. There's so much stuff that I haven't even done yet in this, but the possibilities are endless.
Yeah,
we can probably do a deep dive into that next time and go over all of these settings and make it a little bit more secure and cheaper, probably also.
Yeah, typically, we can, if you're just starting out with any module or any resource, start with all the required variables. Like you see, a lot of these are optional. Start with the required, and then once that's deployed, add on the pieces that you actually think are necessary. So, like maintenance policy. Do you need it? If you do, put that block in there.
Yeah.
Sure. This stuff actually looks better than Azure's, which is nice.
Okay, the cluster's now created, which is great. So that's normally the longest that it takes. So yeah, 7 minutes, and then this node will probably a couple minutes will be finished, and then we can show you in the console that it's done, and then we'll take off. So what that's creating now is a node pool as well. So if we go node pool, so you don't need to create a separate node pool. You can just have the cluster and then specify nodes, but generally I like to have separate node pools as well. And this is actually the word that we were looking for, is preemptible instead of the transient. So that's the same thing essentially in Google terminology. Then yeah, this is what I was talking about before about referencing the variables. So see how I'm making this cluster, and then I'm referencing the cluster ID here.
Mm-hmm.
Yeah, so that's actually, let's go to the cluster will be up now as you're making the node pool.
Yeah, the cluster would be up, and you can actually just see as well as a start what's in there.
So see here, that's our cluster that was spun up with our variables. It's in the location US West 1, which we specified. Have a number of 2 nodes at the moment. Yeah, so you can see that it's in our network that we made with the subnet, the side blocks. And yeah, that's pretty much the example. So that'll be creating the node pool now that it's probably done. And then that's how you can spin up a cluster in GCP with Terraform. So yeah,
copy the
thanks
code,
everyone for
fork
coming.
it, and just try it out yourselves. Essentially, it's almost like a plug and play thing. You just replace a few of those variables, and you should get your cluster.
Yep. All right. Thanks everyone for coming, and see you at the next time. And if anyone wants to do one of these talks, please reach out, and we're more than happy to have you do one.
All right.
Thanks everybody.
Thank you, everyone.